Welcome to Isothermal Corrugating, a collaboration of Cargill and Kohler Coating, bringing together the best of Cargill's rheology control and adhesive technology and Kohler's patent-pending thin film metering technology. Do you think these production improvements are achievable while still producing a flat board with equal or greater ECTs and pins? The answer is yes. If you're interested in better board, reduced waste, lower production costs, and higher profits, then take the next 5 minutes to learn how it's all possible with the isothermal process. Isothermal corrugating is a unique patent-pending process that optimizes paper temperature and moisture in order to maximize board quality. An isothermal corrugator is essentially a corrugator operating in a manner in which the temperature of the board remains virtually constant over the entire speed range. Starch consumption is not the real problem in corrugating. It represents a very small fraction of your overall costs, but it is a tremendous indicator of whether or not your corrugator is in control. Isothermal corrugating essentially provides automatic temperature control of the process by using water at its evaporating temperature. This natural temperature control will prevent damage to the paper fibers and properties like water drop penetration time. Both TAPI and FEFCO standards say that 185 to 195 degrees Fahrenheit is the optimum temperature for the gelatinization of starch. This is the temperature that we maintain by applying a thin film of water to the medium and liners. Surprisingly, adding controllable moisture is the solution and not the problem. If you take a look at these two graphs, they compare the curve of water and starch consumption on a traditional corrugator on the left and with an isothermal corrugator on the right. A traditional corrugator puts a lot of water and a lot of starch on at the lower end of the speed range. Isothermal corrugating enables you to flatline the starch at all speeds. Isothermal corrugating uses less total water during the entire process, and we adjust for the effects of speed and temperature by using the added control of the water decks. There are 3 simple steps that are involved. Apply water, apply heat to the side that you applied the water, and then apply a rheology-modified adhesive. Let's take a look at a few current installations. First is an isobar glue machine with an integrated water deck. Kohler custom builds each water deck specific to your corrugator's size requirements. As you can see in this recent installation, the compact water deck is very small and leaves a minimal footprint. The machines are completely automatic and require very little attention from the operators on the floor. The biggest changes these machines have on your plant are the huge financial savings and improved board quality. For really space-restricted corrugating lines, we offer an even smaller version, the micro water deck. In this particular application, the customer really didn't have enough room to install the water deck beside their preheater, so we simply raised the preheater and put the water deck underneath. We've mounted water decks above and below preheaters. As you can see, this application can be installed on any corrugator. Isothermal corrugating has specific adhesive film thickness requirements. Let's take a look at an isobar glue machine where we've got a 3,000th or 75 micron film thickness of starch on the roll. It's almost translucent because it's so thin. Isothermal corrugating allows us to use these kinds of film thicknesses because we change the flow characteristics of the adhesive with the addition of Cargill's Fast Break rheology modifier. Without Fast Break, adhesive film thicknesses lower than this are not possible because of the physical and chemical limitations. Look at how sloppy typical pearl starch on a traditional glue machine performs. Look at all the slinging going on, all the number of uneven areas where the starch has not flowed correctly on the roll. This is a typical starch formulation without Fast Break rheology modifier. Think about how much starch is not being picked up by the flute tip. Now, look at the same machine, same speed, with the Fast Break rheology modified starch. You can now see limited or no slinging. The flow of the starch film on the glue roll is much more even, which results in a higher flute tip transfer rate, thus giving a better bond. We all know what the glue gap limitations are with a typical single facer. Look at how these glue gap limitations are affected on an isothermal corrugator. With an isothermal corrugator, you simply adjust the water that is needed relative to the speed. You do not change or adjust the amount of starch. You run a constant glue gap over the entire speed range. This allows for less starch use while accomplishing the same or better level of bonding, achieving the same or better board characteristics at all speeds. An isobar glue machine used with a typical corrugator can reduce starch consumption considerably, as we can see here. But look at the performance of the isobar glue machine on an isothermal corrugator. The glue line stays flat over the entire speed range, and you can even taper it off a little more at higher speeds. Water reduction, the total amount of water reduced in the process, varies over the speed range from about 52% at the lowest speed to 46%. Glue reduction varies from about 64% down to 50% over the speed range at the double backer. This chart represents the speed taken with the temperature gun just as the bottom liner exits the double backer. Something that we all know is when you slow down a typical corrugator, the temperature of the board climbs significantly because you don't have the ability to shed heat as fast as the speed changes. As the line speeds up, even though you might be putting down ballast rolls on a typical double backer, temperature is going to fall off, and then eventually at the highest speeds, the board will be within a range that might be considered acceptable in a typical corrugator. On an isothermal corrugator, you can lower the exit temperature even further, but look how flat the speed curve is versus temperature. As the speed goes from 50 to 950 feet per minute, there is only a 5-degree change in temperature on the bottom liner. Thus the name, isothermal corrugating, where you can now maintain a constant temperature over the entire speed range. The bond is superb at any speed. Over a wide speed range, we maintained exceptional bonding so strong, in fact, that we pull the inner ply of the liner off with the medium, instead of getting failure between the medium and the liner. We'd like to thank you for taking time to let us introduce you to isothermal corrugating and to show you the benefits of the isothermal process. To take the next step, contact our sales team today to schedule an on-site visit at your plant. We look forward to developing a plan that is specific to your individual corrugating needs.